Hello, we are Hydrotech Consultancy, and this is our proposal presentation for the natural gas production plant. This is the process flow diagram for the production of liquefied natural gas, starting from raw natural gas extracted from the reservoir and ending with pure liquefied methane. Before the natural gas is transported to the main process, it needs to undergo several operations at the wellhead. This includes acidic gas control, water removal, and oxygen removal.
The pipes should be made of stainless steel as the pipeline will be underwater and therefore may suffer from oxidation. We have decided that the pipe diameter will yield optimal costs and transport with 2 meters, following the example of the Baltic Sea in which pipes are at depth of up to 200 meters and with a maximum thickness of 41 millimeters. Assuming linear increase at 600 meters, the thickness should be of 117.21 millimeters, which is about 4.5 inches.
We've decided to have two compression stations because the distance between each of them is 120 kilometers.
When considering the types of pumps to use, we gave consideration to centrifugal pumps as well as reciprocating pumps and single-stage pumps and multi-stage pumps. We have chosen to recommend the use of centrifugal multi-stage pumps as they will be able to support the needed flow rate, and having multiple impellers using a multi-stage pump will be better suited to pumping the fluid across the long distances needed. It will also give better hydraulic efficiency.
Moving on to the power plant that is for the topside unit, based on the power requirement or power produced, which is 15 megawatts of power, we have decided to use about 40.3 kilograms per second flow rate of air, which is needed to operate the gas turbine cycle, assuming that it operates at steady state behavior. From this value, we calculated the amount of heat supplied, which is approximately 51,000 and 51,000 watts, and the thermal efficiency of the proposed Brayton cycle is supposedly 95%. In comparison to other efficiencies of other power cycles, such as coal-fired power cycles and nuclear power cycles, which sit around 50 to 60%, this remarks as a good efficiency value, which and the added benefit of being very thermal efficient.
We've decided to use aeroderivative gas turbines because they supply large amounts of power despite their size, and they can also peak production in minutes, and they're sourced by a wide variety of fuels, and they don't require a coolant because air is a working fluid. And we've also decided to use that with a filter system to ensure that particles don't damage the blades and to extend its lifetime.
Improvements to the process include pure coolants or mixed coolants in cascade cycles. These coolants have evaporation curves that match the cooling curve of natural gas, which improves thermodynamic efficiency due to a minimum temperature difference.
Many factors were considered when deciding between an onshore plant and a floating LNG operation, such as the lifetime of the project. An FLNG facility is expected to last around 20 years or slightly more, while an onshore plant is typically built to remain operational for a minimum of 25 years, with some current plants having been in operation for over 40 years. A floating operation has also the added benefit of being able to relocate after a reservoir has been depleted without needing to lay further pipelines or build another facility. However, due to the needs of the project, where it was calculated that nearly 2 million tons of LNG per year production is required, an onshore plant is needed for the project, as currently the world's largest FLNG operation is only capable of producing 1.2 million tons of LNG per year.
Now for process safety, as we are working on offshore with pipes, we have to consider that most large offshore pipelines require safety guidelines to avoid any accidental and implication to the workers on site and the environment. Blockage of pipe due to build-up of the substance such as asphaltene or dirt can cause inner pressure to increase. Therefore, asphaltene build-up inhibition is needed. Leak detection system is also important to ensure there is no leaking that can ignite flammable or hazardous substance. Underground pipe have the tendency to burst due to hydrostatic pressure underground. Therefore, other than ensuring high quality pipe is used, you also have to ensure there is pressure monitor and a pressure relief valve on site.
To wrap up our discussion, we have recommended a couple of improvements and recommendations in order to improve the power consumption and also maximum yield of pure liquefied methane from the project, which is we have decided to use an aeroderivative gas turbine to filter unwanted debris. We also recommend using coolants in cascade cycles in order to maximize power consumption efficiency, and also in order to improve and reduce costs, we also propose that we should use an onshore LNG operation. Also, at the cost of reducing computational effort, we have employed a couple of assumptions, especially during calculating the power requirements for the topside unit, which, for example, we have decided to employ the assumption that air behaves like an ideal gas. So in order to reduce the power consumption efficiency, we could base the calculation more on real life situations. That is from us. We are Team 19. Thank you.